Welcome back. Lesson 7 Sets, Power Sets, Cartesian Products. Introduction. A set is an unordered collection of objects called elements or members of the set. A set is said to contain its elements. We use the symbol this symbol represents element of. We write A is element of capital A to denote that A is an element of A. The notation E with a slash across stands for is not an element of. A is not an element of. A is not an element of capital A. Commonly, sets are denoted by uppercase letters, whereas elements or members of the set are denoted in lowercase letters. The roster method of describing a set is by listing members between braces. You see, for example, the set capital V is braces AEIOU, or capital A is braces 1, 2, so on, 100, or capital N is set of, so these are counting numbers, right? Set of counting numbers 1, 2, 3, dot dot dot. That means it goes on infinitely. Braces. So for example, write down the set of all positive odd numbers less than 100 in roster form. So let's say O, right? You would say, use braces. I'm looking for positive odd numbers 1, 3, 5, 7, comma, dot, dot, dot. Okay, until 99. This is one way of writing. So this is the roster method. You could use dot 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 because there are many numbers in between, or you could actually list them until 99. Okay, that's the set of odd numbers, positive odd numbers less than 100. Now here is another way to describe a set using what is called set builder notation. For instance, the set of all positive odd numbers less than 100 can be written in set builder form as O is set of all those members x greater equals 1 such that x is an odd number less than 100. So you see, greater equals 1 ensures my numbers are positive, and then here is the condition, x is an odd number less than 100. Okay, another way of writing the same set in set builder notation would be, you could simply say O is set of all those members x such that x is a positive odd number less than 100. You could simply state the entire condition here. Okay, next. Here are some important sets we must be comfortable with. N with a highlighted line there is the set starting from 0, 1, 2, 3, so on. This is called the set of natural numbers. Z with an extra line there is the set of integers. You have 0, 1, 2, 3, so on, -1, -2, so on. So you see it's unending in both directions. Z plus is the set of positive integers. You start with the positive numbers 1, 2, 3 and continues forever. Q, the Q with an additional line, this is a set of fractions P over Q such that P and Q are integers. and q should not be 0 because in a fraction we don't want denominator to be 0. This set is called the set of rational numbers. R with an extra line, that's the set of real numbers. R plus, the set of positive real numbers. C, the set of complex numbers. Here are how we describe intervals. Bracket a comma b bracket, that's the set of all real numbers x such that that vertical line is red such that a is less equals x less equals b, that is x is between a and b. Okay, close braces. Bracket a open b parenthesis represents open interval, bracket represents closed interval. So closed A, open B is the set of all those x's such that x, A is less equals x and x is less than b, strictly less than b. Open A comma B closed is set of all those x's such that a is less than x, x is less than or equal to b. Open A, open B is the set of all those x's such that a is less than x less than b. Okay. Note, closed AB is closed interval while open AB is an open interval. Note, we are allowed to have sets as elements of other sets. For example, here is a set with two members. Each member is a set in turn. This is set of natural numbers, this is set of complex numbers. So the outer set, the set we are looking at, has only two entries, has only two elements. Each element is infinitely big. In computer science, there is a concept of data type or simply type. A data type is just the name of a set together with a set of operations that can be performed on objects from that set. Okay, so for example, you could think data type of integers. You could also think data type of strings. So operations on strings are different from operations of data of integers and so on. Two sets are equal if and only if they have the same elements. That is, sets A and B are equal if and only if for every x in A, for every x, x is in A, if and only if x is in B. Okay? So, the way technically I should read, for every x, x is an element of A if and only if x is an element of B. We then write A equals B. For example, the set containing 1, 2 is equal to the set containing 2, 1. Notice order does not matter. The set containing 1, 1, 2, 2, 2. Now this is poorly written. In a set, elements cannot be repeated. So we never use this way of writing. We simply write it like this or like this. Here on, we insist that elements do not repeat in a set. The empty set or the null set is the set with no elements. It is denoted by braces with nothing in it or just phi. Okay, this variable is called phi. Note, the set containing phi is not empty because this set has something in it, one thing in it. Therefore, this one, the outer set is a singleton set. It contains one element. Singleton set is a set consisting of exactly one element. What we have described here is naive set theory. This description is due to the German mathematician Georg Cantor. Let's continue in the next video.